All right, let's get into it. Today, we're going to put on our detective hats and become data investigators. Our mission? To uncover the hidden relationships all around us using a few really powerful statistical tools. Let's dive in. So, every good investigation needs a case file, right? And ours is a question I'm pretty sure you've asked yourself. Does putting in more hours with the books actually get you a better grade on the test? I mean, it seems like a no-brainer, but a good investigator never, ever assumes. We need to see the evidence. So, to actually see the evidence, we need our first and most important tool. I want you to think of the scatter plot as your trusty magnifying glass. It lets us take a whole mess of data points and put them on a chart so we can finally see if there's a pattern hiding in plain sight. Now, in any case, you've got two key players. First, there's the explanatory variable. Think of this as the influencer, the one we think might be causing a change. In our case, that's hours studied. Then you've got the response variable. That's the outcome, what happens in response. Here, that's the exam score. We're trying to figure out if one affects the other. Okay, so when you're looking through that magnifying glass, your scatter plot, what are you actually looking for? Well, you're searching for clues, and there are two main ones to start. First is direction. Are the dots generally going up and to the right? That's positive. Or are they going down? That's negative. The second clue is form. Do the points look like they're clustering around a straight line? We call that linear. Or is it more of a curve? Let's get back to our case. When we plot the data for study hours versus exam scores, well, the evidence is pretty obvious. The points are definitely trending upwards, so that's a positive direction. And they seem to group up pretty tightly around a straight line, so that's a linear form. The visual evidence is screaming that there's a connection here. But here's the thing. A good investigator can't just say, it kind of looks like there's a connection. Nope. We need to measure it. We need a hard number. And that brings us to our second tool, a precision instrument called the linear correlation coefficient, but we'll just call it R. So what exactly is R? Well, it's this awesome single number that tells us two critical things. The direction, is it positive or negative, and the strength, how tight is the connection. And notice that word in there, linear. This is super important. R is a specialist. It only measures the strength of straight-line relationships. Now, you might see the actual formula for R and your eyes might glaze over a little bit. It can look pretty intimidating, but don't worry about it. For our investigation, we're not going to be crunching these numbers by hand. What's absolutely crucial is just understanding what that final number actually means. So this R value, it lives on a scale from -1 to +1. That's it. Let's look at the extremes. If you get an R of exactly -1, boom, you found a perfect negative linear relationship. As one thing goes up, the other goes down in a perfectly straight line. Now, what if R is 0? That means there's absolutely nothing. No linear relationship anyway. The data points are just a random cloud on the graph. There's no straight line pattern at all. And on the flip side, an R of +1, well, that's a perfect positive linear relationship. As one variable goes up, the other one goes up right along with it, and all the points fall perfectly on a single line. Of course, in the real world, things are messy. You almost never see a perfect -1 or +1. Most of the time, the answer is somewhere in between. So think of this table as your field guide, your cheat sheet for interpreting R. You know, if you get a 0.8, you can say, hey, that's a strong relationship. If you get a 0.2, you know it's very weak. This gives us the language to talk about our evidence. Okay, we have our tools, we can see patterns, we can measure them, we're feeling pretty good. But now comes the most important, the most critical part of an investigator's training. This is the golden rule you can never, ever forget. Get this wrong, and you could draw a completely wrong conclusion. And here it is. I want you to burn this into your brain. Correlation does not imply causation. Just because two things are moving together, even if you have a crazy high R value of 0.95, it does not by itself prove that one thing causes the other. This is the big twist in so many stories. So if one thing isn't causing the other, what the heck is going on? Well, a lot of the time, there's a third party involved, a hidden character we didn't even know was in the story. In statistics, we call this the lurking variable, and this is often the real culprit. Basically, a lurking variable is some other factor that's not even in your study, but it's back there pulling all the strings. It's affecting both of your variables, making it look like they're connected, when really, they're both just reacting to this hidden influence. Let's crack open another case file, a classic. If you were to plot the data, you'd find a really strong positive correlation between how much ice cream is sold and how many shark attacks happen. So, does eating a scoop of ice cream make you tastier to sharks? No way, right? Of course not. And this shows the idea perfectly. The lurking variable here, it's the weather. It's that summer heat. When it gets hot, what do people do? They buy more ice cream, and they go swimming in the ocean more often. The heat is the real cause that drives both things up, creating a fake correlation between them. Okay, you're getting the hang of this. Let's try one more. You look at data and see a strong positive correlation between the number of fire trucks at a fire and the amount of property damage. So, should we just send fewer fire trucks to limit the damage? Absolutely not. You know the answer. The lurking variable, the real culprit, is the size of the fire. A huge fire needs a ton of trucks to show up, right? And that same huge fire is what's going to cause a ton of damage. The trucks aren't causing the damage. They're both just a response to how big the blaze is.
So, where does this leave us? What have we learned on our little investigation today? Well, we've built a pretty solid toolkit, and now we're ready to take the investigator's oath, to use these tools responsibly to find the real story hiding in the data.
So here it is, your official investigator's toolkit. Step 1, always start by looking at the evidence. Visualize it with a scatter plot. Step 2, check the scene for direction and form. Step 3, get a hard number. Measure that linear strength with R. And the last 2, the big ones. Step 4, always remember the golden rule. And step 5, go on the hunt for that sneaky, lurking variable. And that's really it. You're now equipped. The next time you see some headline screaming about how two things are linked, you'll know how to think like an investigator. You can look right past the obvious and start asking the really smart questions. So I'm going to leave you with this final question. As you go about your day, start looking for these correlations. You'll see them everywhere, in the news, online, all over the place. And now that you're an investigator, what do you think the real story might be?